Welcome back, everyone, and thank you for being so enthusiastic and eager about learning how to solve a quadratic equation. Before we get to that, you might have noticed that in Schoology, there was a little different way that I embedded the video. Normally, I just put the video file, put it right into your assignment on Schoology, and then you click on it and watch it. This time, what I did is I gave you a link that takes you to a YouTube channel, and I'm going to explain why I did that. So here's a look at my YouTube channel over here. It shows all of the videos that I've made for this class and then also my Algebra 1 class thus far. And if you look down the left side, it has some words like dashboard, videos, playlists, analytics, comments, subtitles, monetization. So this one right here, monetization, that one got my attention. So let's go ahead and click on that. Essentially what it says is, you will be eligible to earn money from your videos. Ooh, I like hearing that. All I need to do is I need to get from 27 subscribers up to 1,000. So that's where you guys come in. I also need to get from 29 watch hours up to 4,000. So I think this 1,000 subscribers thing might be kind of difficult to do. I mean, I could just make a whole bunch of accounts and hit subscribe. But if you could all just hit subscribe, and maybe tell your brothers and sisters to subscribe, maybe your cousins to subscribe, your parents, your grandparents, your neighbors, your mailman, anyone. Just get anyone that you know to subscribe to my YouTube channel. I know that you guys are going to get to the 4,000 watch hours because you're going to watch all my videos. You're probably going to watch them twice just to reinforce this knowledge. So I'm not super worried about that, but let's get to 1,000 subscribers. When I start making money, I will take 0.5% of my profits and I'm going to give it back to you guys. So when we're back in school, maybe we can have a pizza party, or if it doesn't make enough money to get pizza, maybe some cookies or something like that. So how about that? Now let's go ahead and get to some of the math. So we are going to go to Notability. And we're going to start with our notes on solving quadratic equations. So we've seen how we can use the quadratic formula to find x-intercepts. That's typically what we've used it for. It's also used to solve any quadratic equation. The important part is that one side has to equal 0. So let's look at the first example. 3x squared plus 6x equals -2. Well, that doesn't equal 0. So in order to make it equal 0, I have to add 2 to both sides. So we'll do that first. So we're going to start with 3x squared plus 6x plus 2 equals 0. So I moved that -2 to the other side, and it became +2. Now that it's set equal to 0 on one side, I can solve it with the quadratic formula like normal. So hopefully you didn't forget that song. In case you did, to solve a quadratic formula, it's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So then we're going to take the stuff that's underneath the square root. We're going to simplify that. So if I did 6 squared, that's a 36. And if I take a negative times a positive times a positive, it'll be negative. And 4 times 3 times 2 is going to be 24. And all of that stuff simplifies to be a 12 under the square root. So we're going to go down and we're going to simplify that again. We have x equals -6 plus or minus root 12 over 6. Now you might be tempted to leave your answer like this, and technically you would be correct, but we want it simplified a little bit further if possible. So what I'm going to do is I'm going to take that square root of 12 and we're going to simplify that. And in order to simplify a square root, we have to take out the perfect squares. So a perfect square that's in the 12 is a 4. So I think of that as square root of 4 times square root of 3. And the square root of 4 is just a 2. So that's what I'm going to end up replacing that square root of 12 with. So this becomes -6 plus or minus 2 root 3 over 6. And you might be tempted to stop right there, but this can be simplified just a little bit more as well. So this 6 is dividing both components. This 6 is dividing here, and it's also dividing here. So we're going to take each part and simplify it. If I do this part, negative 6 divided by 6, that's just a negative 1. Oops. So that becomes negative 1 plus or minus. Now if we take this part here, that 2 over 6 can be reduced to 1/3. So it would be written as square root of 3 over 3. And those would be your two solutions to this quadratic equation. So typically there are going to be two solutions whenever you do a quadratic equation, but we'll get to that later with the discriminant. Let's go ahead and look at what we just found. If you look at this graph in black here, this is the graph of 3x squared plus 6x. So I graphed that right here in black. Essentially what we did is we found where it equals negative 2. So I'll highlight this new graph here in red. Here's where y equals negative 2 in red. So essentially what we did is we found the points where that original graph, 3x squared plus 6x, was equal to negative 2. And it shows up at negative 1.5774 and negative 0.4226. All of the answers that we had were given in exact answers here. If you'd type this in the calculator, those are the two decimal answers that you would get for your answer. So they're equivalent. The reason I ask for exact answers is because then you can't just go into Desmos and type in or get those answers that easily. You have to know what you're doing. Let's go ahead and do one more example together. Negative 2x squared plus 12x minus 18 is equal to 2x minus 9. So first, we have to set one side equal to 0. And to do that, I'm going to subtract 2x from both sides. And I'm also going to add 9 to both sides. And by doing that, that goes away, that goes away. Now the right side is going to be equal to 0. So we are going to be left with negative 2x squared. 12x take away 2x is going to be a positive 10x. And negative 18 plus 9 is minus 9. Equals 0. Make that a 10. Now we have a quadratic equation that is set equal to 0, so we can go ahead and use our quadratic formula. And you're probably already singing it in your head, but in case it's not in your head, I'm going to put it in your head. X equals negative b plus or minus the square root of b squared minus 4a. Sorry, I'm slow. C all over 2a. And that's a negative 2. And then again, we're going to do the same as before. We're going to simplify this stuff underneath the square root. So 10 squared, that is just 100. If we take a negative times a negative times a negative, that would be a negative. And then we have 4 times 2 is 8. 8 times, it looks like a 7, but it actually is a 9. Sorry. 8 times 9 is 72. So all of the stuff under the square root, that will just simplify to equal a 28 under there. So we're going to rewrite it now. We have x equals negative 10 plus or minus the square root of 28 over a negative 4. Now once again, we can take that 28 and we can simplify that by pulling out a square root, or a perfect square. So a perfect square that's in there is again a 4. You can think of that as square root of 4 times the square root of 7. And the square root of 4 just simplifies to be a 2. So we get 2 root 7. So let's rewrite that. So negative 10 plus or minus 2 root 7 over negative 4. And once again, we can simplify this a little bit. If we take this first component, the negative 10 over negative 4, that's going to be reduced by 2 on the top and bottom. So it ends up becoming 5 over 2. And we have plus or minus. We can divide the top and bottom here by 2 as well, so we get root 7 over 2. You don't really need to worry about the 2 divided by negative 4 being a negative, because we've already accounted for the plus and minus version of it. So this would be your final simplified solution. And once again, I just want to show you briefly what we just found, because I think it's important to understand what the question is asking for. So let's take a look on Desmos. We'll get rid of those 2 graphs we just dealt with. And I'm going to highlight 2 more. The first graph that I'm going to highlight is the graph of negative 2x squared plus 12x minus 18. It's this graph over here. And the next graph I'm going to highlight is this one here in green. That's this side. It's 2x minus 9. What we were actually doing by solving this quadratic was we found where those 2 graphs are going to intersect. And it's at 3.8 and 1.2 approximately. You could take the answers that we just found over here, turn them into a decimal, and you'd get 3.8 and about 1.2. So it shows you where those 2 graphs are going to intersect. So we're not always finding x-intercepts when we use the quadratic equation. We're finding where a quadratic is equal to something else. In this case, we found where a quadratic was equal to a linear function. And go ahead and try the next couple examples on your own. And when you are done with that, go ahead on Desmos, double check your answers, make sure that you got them all correct. And then come back and you will get to learn about the discriminant.